Hello everyone, my name is Haitham Suleiman and today we are going to continue to solve our physics problems in Form 1 and then today our topic is going to be Introduction to Laboratory Practice. Okay, we see here our first question says, answer the following questions briefly. Answer the following questions briefly. A. What is physics laboratory? And B. List 5 laboratory rules. Okay, so in physics, we have to make some experiments, right? In experiments, we have to go to special rooms. These rooms are what we call laboratories. Let's see the answers to our questions. Okay, here we see that a physics laboratory is a special room that has been designed and equipped for carrying out scientific experiments for a purpose of study or research. Great. Here we have some words that we need to consider. The first one here is said it is a special room that has been designed. This statement we have to consider and equipped for carrying out scientific experiments for a purpose of study or research. These four statements here that I have highlighted, they are very important in answering these questions because these are what makes a physics laboratory different from any other special room, any other room. Okay, so a physics laboratory is a special room that has been designed. So we should have a room that we have specially designed and equipped. To equip means to put some equipment, some tools in that room for carrying out scientific experiments. As I said before, scientific experiments are all activities that are specifically handled and taken care of so as to get certain results for the purpose of study or research. Yes. So we can see here that in a physics laboratory, we do these experiments so as to study maybe some certain phenomena or research. We have to research about something, so we go to the physics room, physics laboratory, and then we perform a certain experiment that we want to research on. So simply we can define a physics laboratory as a special room that has been designed and equipped for carrying out scientific experiments for a purpose of study or research. Okay, and then here number letter B says list 5 laboratory rules. Okay, so this special room is not like any other. This is a very special room and it has certain rules that you as students have to follow before entering or while entering or before leaving that room. We are supposed to list 5 rules and here are some of those rules. Number 1 says, the first rule says, do not enter the laboratory without the permission of your teacher or laboratory assistant. This is very important because in the laboratory rooms, we have some dangerous chemicals that we put there. We have some heavy machines that might be very harmful when they fall on you. You see? So that's why you should never enter a laboratory room without the permission of your teacher or laboratory assistant. That is the first rule. The second rule says, avoid running, screaming, or playing in the laboratory. You should never run, you should never scream or play in the laboratory. Laboratory is not a room to be played for. You see, this is a special room for carrying out activities, experiments, right? So, because as I said, we have some dangerous chemicals in there, we have machines. So, when you run, you might make those machines to fall or damage those machines. So, you should never run, scream, or play in the laboratory. That is the second rule. The third one, avoid testing, eating, or drinking anything in the laboratory. In laboratories, we are going to have some salts, we're going to have some other kind of materials that can be eaten if you like, you're curious to try, but you should never do that. You should never test, you should never eat or drink anything in the laboratory. If you do so, that might be harmful, you see. And then the fourth one is never use bare hands to handle hot objects. So in the laboratory room, we are going to do some heating activities. We are going to put the flames and heat. Maybe you are going to heat a salt. Maybe you're going to heat some water. So if you use your bare hands, you might burn your hand. So the first rule is you should never touch hot object with your bare hands. You should wear some sort of gloves that your teacher or the assistants are going to give you, so as you can touch those hot objects. The fifth rule says clean the working area before leaving the laboratory. So once you have finished doing your experiment, you need to make sure that you keep everything in its place. You need to clean to make the place neat. You need to keep the laboratory neat before you leave the working area, so that the person who comes after you can find if everything that is needed easily, and that too you are actually helping him. Okay, so let's go to the second question. Let's go to the second question over here. And it says, name, it says, name the following, no, answer the following questions. A, what is first aid? B, what is the first aid kit? And C, list 5 items found in the first aid kit. Right. So maybe you meet someone who have met with an accident, right? So before you take him to the hospital, you have to give him first aid. So let's answer the first question, which says, what is first aid? It says here, first aid is the immediate assistance or care given to a sick or injured person before getting professional medical help. So when you see someone who have been, maybe that person has met with a minor or major accident, and you want to help that person, that activities that you are doing are what we call first aid. The assistance or care you give to that sick or injured person before getting professional medical help, before sending that person to the hospital, is what is known as first aid. So, and then in first aid, we have a first aid kit. This is like a box. So it says here, first aid kit is the box containing items that are used to give help to a sick or injured person. When someone has already met with an accident, right? So you need to help that person. Maybe you need to stop the bleeding. What are you going to use? Obviously, you have to use a certain box, which is called the first aid kit. And in that box, there are many items found that can help you to help that person who is injured. So that box is what we call the first aid kit. So number C, letter C says list 5 items found in the first aid kit. So I have listed here some items, 5 of them. The 5 items found are painkillers. In a first aid box, you're going to find some painkillers, maybe paracetamol, Panadol. These painkillers are used for relieving pain, because when someone gets injured, so she or he is in very deep pain, very deep pain. So how are you going to help him? The first thing you could give him is a painkiller that relieves, that helps to lessen his pain and giving him relief. Second, you're going to find thermometer. Thermometer, it is used for to measure the body temperature. Thermometer is actually some kind of device that you put in the mouth, or you can put here in the armpit, and you can measure the body temperature of that person. If that body temperature is actually higher than the normal ones, and for like human body it's supposed to be 37, so if it's higher than 37 degrees, that means that person is running a very high fever. So the thing that you can know if that person has high temperature is known as thermometer, that instrument. And then you are going to find bandages for cleaning and covering the wound. Maybe say that person has cut his hand by using a knife. So in the first aid box, you are going to find this item called bandage. You can clean and you can cover the wound by using that bandage. And then the next item you're going to find is soap. We all are familiar with the word soap. It is used for washing the wound, and equipment. So you have your equipment, you have your bandage, you have your thermometer, maybe you have some nails that you want to you have already used, so you can use the soap to wash your equipment, or you can wash the wound. You want to wash the wound, so you have to use soap. And then the last thing that we can find is scissor, is scissors and razor blade for cutting the dressing materials. If you want to cut maybe your bandage, you have to use some material, and that material is what we call scissor and razor blade. These can also be found in the first aid box, so that you can cut the dressing materials like bandages. Okay, let's see the third question here, and it says, state five classes and their most appropriate five state five classes and their most appropriate fire extinguishers. This is supposed to be state five fire classes fire classes and their most appropriate fire extinguishers and their most appropriate fire extinguishers. Okay, so we know that there's fire in this world, right? But actually, there are different types of fire classes. To group them, we have five groups. As it can be seen here, we have class A, we have class B, we have class C, we have class D, and we have class E. And these fire classes have different burning materials. Some fires burn in these types of materials, while others burn in certain other type of materials. So for class A fire, the burning medium is organic solid, wood, paper. So maybe if you have a paper and you lit a matchstick and then you see some fire, we call that fire as class A fire. And how can you extinguish it? How can you make it go off? By using water. And then we have class B fire over here. And the burning medium is flammable liquid like petrol, like diesel, like alcohol. That fire that results from this petrol, alcohol is known as class B fire, and you can extinguish it by using dry powder. And then we have class C fire, and the burning medium for class C fire is flammable gases. Example, methane. So there's this gas. It's called methane. Okay, so here I have encountered a word which says flammable. I suppose you're familiar with the word flammable as in like chemistry, but flammable means something that can catch fire. So if you see somewhere it's written flammable, it means it can catch fire easily. So for class C, we have flammable gases, example methane. There's this gas called methane. And how can you extinguish it? By using dry powder. So maybe let's say you are walking and you see this big cylinder, it's red like, and that is known as fire extinguisher, and it has dry powder inside used to extinguish these class C and class B fire. Remember, fire in papers or woods or in clothes cannot be extinguished by this powder. You have to use what? Water. Okay, and then we have class D fire. Class D fire, the burning medium for class C fire is combustible metals like magnesium, sodium, and others. So we have these metals, magnesium and sodium, which can catch fire, and these are known as combustible metals. And maybe you have this metal and it has already catch fire. How can you extinguish it? By using again dry powder. And then we have the last type of fire. It is called class E fire, and this is obtained from its burning medium is electrical hazard. Electrical hazard, which means it is like related to electricity. Like here it says damaged electrical cables. So maybe you see that you hear someone saying his house has caught fire from electric shock. You see, so you should immediately know, oh, that is type E fire. That is class E fire. And how can you extinguish it? You can immediately extinguish it by using carbon dioxide. We have two types. We have mainly gases known as oxygen, carbon dioxide, right? So you can extinguish this class E fire by using carbon dioxide. Okay, so let's look into our fourth question, and it says to write true or false? Okay, so in order to know if it's true or false, we have to first read the question very carefully and we have to think, is it true or is it false? And then we write. We should not just assume like others do by crossing fingers. No, you need to think. Okay, so let's look at the first. It says you should move a victim of electrical shock using a metallic object. You should move a victim of electrical shock using a metallic object. So this person has got electric shock, like he's doing like this. So how are you going to help him? Should you move him by using a metallic object? Maybe you take nail or you take something that is made of metal and then you move him from that spot? No, because that might actually transfer the electric shock to you. So you should not move a victim of electric shock using a metallic object. So we are going to write here false, because this statement is false. You should never move someone who has been hit by electric shock by using a metallic object. Let's look at the B here. It says first aid help to preserve life. Okay, so what did we say first aid was? We said it was the immediate help given to a person, a sick or injured person, before seeking medical assistance, right? So you give that person an immediate help. You stop, maybe he was bleeding and you stop it. Does that help to preserve life? Yes, it does. Because if that person bleeds too much, then he would lose blood and he would eventually die. So when you stop the bleeding, you give first aid, you help to preserve life. So this statement is absolutely correct. So we are going to write here true. Okay, great. Let's look at letter C here. It says thermometer used to measure body temperature. Okay, I said thermometer was an instrument that is used to measure body temperature, right? Maybe you encounter someone and you want to check if that person has high fever or not. You have to use thermometer. So actually, thermometer is used to measure body temperature. So this statement is correct. So let's write here true. We are going to write here true. Let's look at D. D says eating in laboratory is prohibited. Is eating in the laboratory prohibited or allowed? As we said, the word prohibited here means it is not allowed. So when you hear something is prohibited, it means that thing is not allowed. So is eating in the laboratory allowed? No. So it is prohibited. So this statement, eating in the laboratory is prohibited, is actually true. So we are going to write here true. And let's look at number E. Let's look at E here. It says a micrometer screw gauge is used to measure internal and external diameter of a test tube. Okay, so a micrometer screw gauge is a device that your teacher, when he or she takes you in the laboratory, should be showing you that. This device is actually used to measure the diameter of a wire. You want to use a certain wire and you need to know what is its diameter. So how are you going to know? You use this device known as micrometer screw gauge. So here in the statement it says it is used to measure internal and external diameter of a test tube. Look at the hint here, test tube. You cannot measure the diameter of a test tube by using a micrometer screw gauge, because micrometer screw gauge is only used to measure the diameter of a wire. So this statement here is tricky and its answer is false. So let's write here, this is a false statement. And with this, we have finished our fourth question about true and false. Remember, when you do true and false questions, you have to stop and think before answering. Let's continue with our fifth question that says, write the steps for the scientific investigation. So in this question, we are supposed to write what scientists, how many steps do they do when they want to investigate on a certain fact. Investigation is just an experiment or study that deals to look at how the facts are and what are the results obtained from those facts. So our answer is, here is our answer. The first step is problem identification. This is the first step of scientific investigation. Okay, in all this series, what I'm going to talk about, the example I'm going to use is going to be the pendulum bob. There's this small metal ball, it's called bob, and then we keep it at one height, and then we let it to swing. Once it swing, we use it to calculate the time period, the time it takes to complete one oscillation, right? So maybe we want to measure, maybe we have discovered that the mass of that bulb, that metallic ball, affects the time period to complete one oscillation, right? So that is the problem identification, that mass of the bulb affects the time period of the bulb. Now the second step is going to be asking question. So now that I have met this puzzling observation, mass does affect. So now the second step is going to be, I'm going to ask some questions. I'm going to ask, like, does the mass really does the mass of the bulb really affect the time period for it to take to complete one oscillation? That is going to be my second step, and it's asking questions. And then the third step is going to get to be formulating hypotheses. This word hypothesis here means an intelligent guess. So you are trying to guess the answer. Maybe, yes, the mass of my bulb, it affects the time period, or the mass of the bulb does not. You make your own guess. So here I'm going to assume that yes, my hypothesis is going to be the mass of the bulb affects the time period of it to complete one oscillation. And then we're going to go to our next step, that is our fourth step, is performing experiment. Remind you that an experiment is any activity done under controlled conditions. In an experiment, we have to use variables. Variables are the things that we can keep constant or we can change so as to get the required results. Maybe in our experiment, we have the mass of the bulb, we have the length of the string, and then so we are going to maybe to keep our length constant, and then we are going to change the mass, and then we are going to observe what happens. These controlled activities are what we call experiment. Then after performing our experiment, we are going to our fifth step, that is going to be data collection and analysis. Here we have to collect the data and then we have to analyze it. So how are we going to collect the data? We can collect it by making some table. So maybe we could draw our table here, and here label mass, and then here label time. And then we could try to see, maybe if our mass first was 2 kilogram, maybe it was 2 kilogram, and then we discover that the time period was, let's say, 3 seconds. And then we later change our variable, which is mass, and then we now put it into 4 kilogram. And then we see that still the time period is 3 seconds. And then we later change the mass again to, let's say, 8 kilogram, and see still that our time period is 3 seconds. So this is how we collect our data in the form of table, and now we have to analyze it just like how I did. And then our sixth step now is going to be data interpretation. We have already tabulated our information. Now we want to interpret our data. To interpret means to comprehend, like to understand, what does our data tell us, right? So from the table that we can see, from the table here, this is our table, we can see that we have changed the mass, but the time remained constant, right? So we can say that we can know from here that if we change the mass, the time period of the bulb still remains constant, that is 3. And then the next step is going to be to present our data. So we have already done our experiment, we have already collected our data, we have already interpreted. And like in this case, we have already seen that We change the mass, but the time is constant. So now we have to present. How are we going to present? We can present it in many different forms. We can use pie charts, we can use graphs. Like in this case, I'm going to present it by using graph. So maybe I could plot my graph of my graph of time against mass. I could plot my graph here of time against mass. So here, let's say this is 3 seconds, this is 6 seconds, and here this was 2, this was 4, this is 6, and this is 8 kilograms. Mass here we have in kilogram, and our time here we have in seconds. Right. So we can see when our mass was 2 kilogram, our time period was 3. When our mass was 4 kilogram, our time period was 3 again. When our mass was 8 kilogram, our time period was still 3. So from here, we can simply draw a line here which passes over our point. So this is how we have presented the data that we collected in the form of graph. And then the last step is going to be to draw conclusion. Conclusion is the summary of the results that you have obtained. That is the conclusion. So you have already identified your problem. You have already asked yourself some questions. You have already formulated your hypothesis. You have performed your experience and collected the data. You have interpreted and presented the data. So now, what should be your conclusion? Your conclusion should be directly going back to your hypothesis. Remember, I said hypothesis was your intelligent guess. You already guessed the answer, which in our case, our answer was yes. The mass of the bulb affects the time period. But according to our experiment and collection of data, we saw that the mass did not affect the time period. We changed the mass, but the time period was constant. So our conclusion went against our hypothesis. So we can just conclude by saying that no, the mass of the bulb does not affect the time that it takes to complete one oscillation or time period. So maybe for further, in order to get reliable information, you can perform this experiment 2-3 more times so as to be sure of how correct your answer is. Thank you.